Good morning, students. I am your teacher Niti Malik. Today we are going to discuss the concepts of field. So, first we should know about the division ring or the skew field. So, what is a division ring? A ring R is said to be division ring if plus operation satisfy the abelian group. Multiplication operation with R star is a group. So first of all, we should know about what is R star. R star is a set in which 0 should not include as an element. Second, we should always clear about the difference between group and a abelian group. So a group became an abelian group if only group satisfy the property of commutative, or we can say if group satisfy commutative law. Third, the set with plus and multiplication operation satisfy the distributive property. So we can say a division ring or skew field should satisfy three things, that is plus operation satisfy abelian group, multiplication operation should be a group, and plus and dot should satisfy the distributive property. So we came on the concept of field. A commutative division ring R is called a field. So what is a commutative division ring? As we know, division ring have three things: plus abelian group, dot group, and distributive property. But if this thing became an abelian group, then this became a field. So how it became a abelian group? If it satisfies the commutative property. So the definition of field says that a commutative division ring R is called a field, or we can say that R star dot operation is a commutative field. So it should satisfy plus operation with the abelian group, multiplication operation is also an abelian group, and plus dot is a distributive property. So we are going to see some example whether they are division ring or not. So consider the ring with the set of integers and two operation, that is plus and multiplication. So set of integers will include 0, plus minus 1, plus minus 2, plus minus 3, and so on. What is set of z star? If we remove the element 0 from z, then it became z star. So it will have the element plus minus 1, plus minus 2, plus minus 3, and so on. So we come to the operation of z star with multiplication. As multiplication always follow the closure property and associative property, so we are going to check only the identity and the inverse property. As we know, for the plus operation, identity element is always 0, and for multiplication operation, identity element is always 1. So in the above set of integers, we have 1 plus 1 as a element. So it satisfied, that is it satisfy the identity property. Next, for the inverse, inverse states that an element A, if you multiply with some element, then it should give the identity element. And previously already we have seen that for the multiplication operation, identity element should be 1. So answer should be 1. We know that. How? Thing is that if A is 2, then from what thing we have to multiply it to get the result 1? So we can only multiply it by 1 by 2 to get the result or identity element 1. But thing is that 1 by 2 is not part of our integers. So R star dot is not a group. So we can say that it also is not a division ring. Now come to the second example. Consider the ring Z4 plus 4 and dot 4. And as we know, if there is a subscript 4, the element should include elements which have 1 less. 4 is here, then 3 will be the largest element in the set. And it is also star, so we don't have 0 element in it. So first of all we have to check for the closure property. In closure property we have these elements 1 2 3 and 1 2 3. As in dot 4 is basically multiplication modulo 4, and we know how we get modulo 4, and we know how we get the modulus operation result. We multiply the sets and divide it by the modulus element, that is 4. The result will be always remainder. So if we multiply 1 by 1 and divide it by 4, we get the remainder 4. If we multiply 1 by 2, we get 2, and if we divide it by 4, we get the remainder 2. If we multiply 1 by 3 and divide by 4, we get the remainder 3. Now in the same way we fill these values here. Now come to this. If we multiply 2 by 2, we get 4, and if we divide it by 4, we get the remainder 0. But 0 is not the set, is not the part of this set. So we can say that this is not a division ring or a field. So we are going to see some example which are fields. You have to learn them. First is the set of real numbers, the set of complex number, and set of rational number are always fields. Just remember it and learn it. That's all for today. Thank you, student. Thank you so much.